Okay, so I want to do a representing motion review. So I guess the first thing to think about on this is that before we started this idea, before we started motion, we talked about models. And the reason why models are important here, I'm going to zoom in a little bit more on this bad boy. Okay, a little bit more. There we go. The reason why models are important is because learning really is a matter of looking at what models are in your head and tweaking them or changing them altogether to come up with better models that represent reality a little bit better. And no model is perfect. It has its limitations. But science is a process really of finding better and better models. So when you think of model, think of a mental model. Yeah, I can't even write. Mental model, or a mental framework, a way to organize an idea with its parts in your head. Like we talked about the calendar year and how that is a mental model. And then science then is really, like I already said, a process. It's not like a collection of facts or information as much as it is a process for finding better models. And yes, it involves facts, and yes, it involves experiments, and some of it was done years and years ago, but it really is like this living thing that we keep getting better and better models and taking the models that we have and refining them, and who knows what tomorrow will bring. Maybe the models that we have will be replaced by something that seems to be better. So back into representing motion. We did motion maps, which, remember, motion maps were the idea that I can represent motion kind of with these little dots. So if I have a car that's speeding up, then it's covering more and more distance every time, and so the dots would get farther apart. If the car is slowing down, then it's covering less and less distance every time, and I can show that slowing down and then drop the point down when you want it to stop. If the car then came back the other way, you could show that it's speeding up as something like this. And you can see that the spacing here at the end is bigger than the spacing at the first. So if it was covering, say, 10 meters in that 1 second, it would be going 10 meters a second. And if at the end it's now covering 15 meters in that 1 second, it's now going 15 meters a second. So imagine that these are like 1 second intervals. That's 0 seconds, and then 1 second, and then 2 seconds, and then 3 seconds, and then 4 seconds. So really the interval, it's the spacing that tells you the distance and the time. So you start at 0 seconds, and then the next one will be 1, and then on and on like that. And I can show changes in direction, I can show stopping, and all that kind of stuff. There are some limitations, because this is saying I stop for a second here, and then I speed up in the other direction. But if you like kind of instantly stopped and then reversed, there wouldn't maybe really be 1 second here. It would be maybe just something like that, and you wouldn't put a dot there. So that's how to do motion maps. So your spacing is important. We did several activities where you had to draw motion maps. The next thing that we learned here was position time graphs. So we have position on this axis, and we have time on this axis. And you had to predict with the motion detectors then how the graphs would look. So if I had a graph that was just like this, imagine yourself standing right here on this line, and you're staying the same distance away from the motion detector because the line's not changing. So this would be stopped or staying in place. If the line is going like this, then you're walking toward the motion detector. If the line looks like that, then you walk away from the motion detector. So you kind of have to understand, some of the basic ideas. A lot of times for position we use the variable x, so we can be lazy and just put x and t here. So if I had some kind of motion that looked like maybe this, flat, and then something like this, and then it curves like that. This would be stopped, and then here I walk toward it, and then here I stop and start basically speeding up away, because this is curving away here like that. So that then leads us into saying the next piece that we learned was about speed. We did the Forrest Gump activity for speed, and kind of remembered that speed is distance over time. But that in physics we have this idea of velocity, which is not the exact same thing as speed versus time, but we can a lot of times think of it as speed and the direction that you're going in. So like speed could be 30 meters a second, but velocity would be 30 meters a second to the right, or to the left, or north, or south. Or it could be 15 miles per hour, and this would be 15 miles per hour north. Giving it a direction makes it into a velocity. But that's the basic idea. There's a little bit of other difference, and let's just talk maybe about that briefly. If we have a position versus time graph, and you have that line versus that line, this one is showing something that's moving faster, and this one's showing something that is moving slower. So the steepness of the line, the rise over the run, is telling you something about that. The rise would be delta y, the x would be delta x, the x-axis. So your slope is rise over run, or delta y over delta x. So I can say that the delta y is really my change in position, and the delta x is really my change in time, because this axis is time, this axis is position, and so velocity then is the slope of that line. So your change in position, though, can be going away or coming back. So that was the idea of change in velocity, or that it includes a direction, I should say. Okay, so that was a lot of what we did. The motion maps and the graphs. Let me think here, what else was there? You're going to need to be able to draw motion maps from a scenario, and also draw graphs from a scenario. You'll also have to be able to read the ones that are there. And those are, I think, the basic ideas for representing motion. If you have more questions than this, come in and see me and we'll go through it. Remember that to retake the test, quiz, you either come in and see me or watch this video, and then do the review retake as well, so both parts.